Hello everybody, my name is Agnieszka Faleńska and I work in the field of natural language processing, which is the subfield of artificial intelligence that deals with processing human language. So if you've ever used an automatic translator or speech recognizer, then it means that at least once in your life you've already used a tool which employs natural language processing algorithms. The title of my thesis is Ensemble Dependency Parsing Across Languages, Methodological Perspectives. And it builds on those two main concepts, dependency parsing and ensemble dependency parsing. So let me start from explaining them. Dependency parsing is this one of those natural language processing tasks which for a given sentence, let's say John saw Mary, predicts something which is called a dependency tree. And this tree is built from words such as John saw Mary and relations between them. So for example, John is a subject of saw, the word Mary is an object of saw, and the word saw is the root of this sentence. So you might ask who or why would we need such structures? Let's go back to this example of the automatic translation. Let's imagine that we would like to translate the sentence, they ate the pizza with anchovy, let's say to Polish. You would really prefer that your system knows that it was pizza with anchovy than if it assumes that the process of eating was done with the fish, right? So how to perform dependency parsing? In general, my thesis is focusing on data-driven and supervised parsers. And there is a big selection of methods with different error profiles. For example, behaving different way depending on the language they are processing. So now let us switch to ensemble dependency parsers. They are those architectures that basically combine multiple parsers into one system. So they still get a sentence, John saw Mary, and they predict a dependency tree. So you might ask, why would somebody like to use an ensemble, which seems more complicated, than just a single parser? If you think of an intuition from real life, then usually we prefer to ask multiple experts when we are making a big decision than just one, right? The same applies to parsing. Let's look at this example here. We will have 3 different parsers, which we will be evaluating on the y-axis with a standard metric, which is called labeled attachment score, and we will see their behavior for 4 different languages. So for Hebrew, they are behaving very similarly. For Latin, we have a clear winner, which is the red one. For Japanese, now the green one is the clear winner, which for German becomes even more visible. So now let's look at the performance of an ensemble, which is the X here on this plot. So first of all, we can see that in most of the cases, ensembles give us a nice improvement over all those models. Even if they don't, they automatically select the model which behaves the best for us. And maybe that's not such a big deal if we are processing only 4 languages, but as a matter of fact, if we zoom out from this plot, then we can see that this is becoming a big problem to do this manually for each of the languages. When we have multiple typologically diverse languages, as in my thesis. So hopefully I convinced you that ensembles are those robust and powerful tools. However, interestingly, they are commonly overlooked in practical applications. And if we look into the literature, they are sometimes referred to as unusable by experts or not a practical solution, which clearly shows us that there is a need for guidelines on designing ensemble architectures. And my approach to this question, how to design an ensemble, was to ask the other way around. So what does the end user know when they want to have a parser? And I thought of those 3 questions. First of all, they know how fast does my system have to be, right? They know how much training data do I have? And also they know, do I need the best possible accuracy? And these types of questions are basically the questions that I answer in my dissertation. So it can be summarized as the systematic analysis of ensemble dependency parsers across typologically diverse languages, where I look into them from three main methodological perspectives. From the perspective of time, I look into lighter and faster ensembles. From the perspective of data, I analyze ensemble parsing in low research scenarios. And from the perspective of accuracy, I look into neural ensemble architectures. Thank you very much.